Hi, in this lecture I will introduce a large topic called event-driven architectures. Also, I will present two simple models for the implementation of event-driven architecture. An event-driven architecture consists of event producers that generate a stream of events and event consumers that listen for the events. To bind the producers and consumers, some kind of event ingestion mechanism must be used. That mechanism can be already implemented in a programming language, or some custom code can be used for that purpose. Events may be delivered in real time, so consumers can respond immediately to the events as they occur. Producers are decoupled from the consumers. It means a producer doesn't know which consumers are listening. Consumers are also decoupled from each other, and every consumer sees all of the events. A very common model to implement event-driven architecture is a publisher-subscriber model. In short, it is referred to as the pub-sub model. In this model, the event producers are called publishers and consumers subscribers. This type of communication is one way. Information flows from a publisher to the subscribers. The publisher creates event information, the subscriber consumes that information. When an event is published, PubSub mechanism sends the event to each subscriber. After an event is received, it cannot be replayed, and new subscribers do not see the event. Let's see the example of a publisher-subscriber model that uses C# language means. Here you see a simple application that just demonstrates how publisher-subscriber works using C# programming language. So let's investigate this program. In the beginning, we have the main method. We will investigate a bit later. And we have several classes and class interfaces. So we have the class message, which has a content variable. We will assign some specific content to that variable. It also has the constructor where we assign specific string to the content. Now we have iPublisher interface. It means all publishers will need to contain event handler and the publish method. Now we have a class publisher that implements iPublisher interface. As you can see, it has handler and implements publish method. To do that, the message is created and method onPublish is called. Now the method onPublish knows the handler or the function that needs to be executed in a subscriber, and in this way it invokes that function. And finally, we have the class subscriber. It has a publisher and subscriber constructor, where the publisher is assigned. So now let's see how this works. In the beginning of the main function, we create the new publisher and two subscribers. We provide the publisher variable for the subscribers. Here you see that we assign a delegate function for publisher handler. In this way, publisher will be able to call this function. What this function does, it simply writes to the console sub1 and the content of the message it receives. The same goes with the second subscriber, which is called sub2. Everything is the same, just that it will write sub2 and the message content. And now we fire the publisher event by executing method publish. Presented publisher-subscriber model fire events in near real time, so consumers can respond immediately to events as they occur. On the other hand, if the consumer subscribed to the publisher later, it will not receive all the previous events. The event stream model eliminates this shortcoming. Events are written to a log. That log may reside inside a file, database, or memory. Events are strictly ordered within a partition and durable. Clients don't subscribe to the stream. Instead, a client can read from any part of a stream. The client is responsible for advancing its position in the stream. That means a client can join at any time and can replay the events. Let's summarize this lecture. An event-driven architecture consists of event producers that generate a stream of events and event consumers that listen for the events. Event-driven architectures promote loose coupling and separation of concerns. Reliability issues may emerge because event consumers don't know the state of the producers. This architecture usually exposes a complex control flow or the order of the code that is being executed. Sometimes events occur unpredictably and it might crash the system. It is easy to understand the paradigm, but the implementation differs across programming languages. This is it. Thank you for watching.